Some of you may not be totally finished with these, but let's go ahead and take a look, see if you're moving in the right direction. Now, I'm going to stick to the dimensional analysis method today because our next step is IV flow rates, and dimensional analysis works out so much better with that. If there's another way that you would like to see one of these problems, whether it's the formula or the proportion method, let me know and I'd be happy to go back and redo them and see one of those methods. So for number one here, we have an order of 0.5 grams of acetaminophen and a supply of 125 milligram tablets. So the first issue we see here is that our order is in grams, the supply is in milligrams. So first thing we're going to do is we're going to go from grams to milligrams. And one equivalency that we should have down right now is that 1 gram is 1,000 milligrams. It's easy to remember the 1,000. The biggest mistake I see is people put that in the wrong place. Remember, the larger unit here is the gram. So you should usually put the 1 with the larger unit so that the 1,000 goes with the smaller unit. So that'll cancel out the grams and put that order in milligrams. Our next step then is to actually convert it over using the on-hand dose and our vehicle, which is what's listed in the supply. And remember that 125 milligram tablets, that's actually giving us an equivalency that 125 milligrams equals 1 tablet. And we can use that equivalency as a conversion factor. So milligrams have to go on bottom so that they cancel out. It's 125 milligrams on bottom is equivalent to 1 tablet. So now the milligrams have canceled out. On top, we have 0.5 times 1,000 times 1 tablet. That's 500 tablets. On bottom, 1 times 1 times 125. 500 tablets divided by 125 is 4 tablets. Any questions on that one? So for number 2, order again is 150 milligrams. We always start with the order. Put it over 1. Our supply, 15 milligrams in 8 milliliters. Again, that is telling us 15 milligrams is equivalent to 8 milliliters of fluid. This is a medication that is dissolved into a solution. That is saying that every 15 milligrams of medication is accounted for in 8 milliliters of solution. We have milligrams here, so we put milligrams on bottom so they cancel out. That's 15 milligrams, 8 milliliters would go on top. So the milligrams cancel. 150 times 8 is 1,200 milliliters. On bottom we have 15. 1,200 milliliters divided by 15 is 80 milliliters. So you would administer 80 milliliters of that medication to the patient. Any questions on that one? Okay, let's move down to the other 2. Number 3 is not very nice. Our order is GRII. That is, remember, 2 grains. Very common mistake to see GR and think grams. Remember, grams is just the G. Now, here to figure out what we want to convert to, of course, we're going to get rid of the grains. So grains are going to go on bottom in our first conversion factor. But to figure out what we want to convert to, we look at our supply. And our supply is in milligrams. So our grains are going to have to go to milligrams. If you look it up, 1 grain is 60 milligrams. That'll cancel out the grains. We are now in milligrams. Once again, 30 milligram tablets is an equivalency. 30 milligrams is equivalent to 1 tablet. Milligrams are on top there, so we put them on bottom here. 30 milligrams, 1 tablet. The milligrams have canceled out. So now our only units is the tablets. Multiply 2 times 60 times 1 tablet is 120 tablets. On bottom, 1 times 1 times 30 is 30. And we just divide it out. 120 tablets divided by 30, 4 tablets. You would administer 4 tablets of that medication. Questions on that? Number 4. Order is for 40 milliequivalents. MEQ stands for milliequivalents. What's a milliequivalent? It is just another unit of measure, just like using milligrams, grains, grams, units. They use milliequivalent. Working with it is just the same as working with any other unit. So our supply is listed as 5 milliequivalents and 3 milliliters. So the milliequivalents have to go on bottom so they cancel out. 5 milliequivalents equals 3 milliliters. Milliequivalents will cancel out. 40 times 3 milliliters is 120 milliliters. On bottom, 1 times 5 is 5. We divide that out. 120 milliliters divided by 5 is 24 milliliters. Any questions there? So that is the basic concept of dosage calculation. That dimensional analysis to me is a much nicer way of going about it, especially for problems like number 3 here, where you have to do a unit conversion along with the dosage calculation. You can do it all as one big long chain instead of having to go through multiple conversions, multiple formulas or portions in order to get that final dosage to be administered. When we left off last week, we had started talking about IV flow rates. And we had mentioned IV flow rates can take on a lot of different forms. We can have milligrams per hour, milligrams per minute, milliliters per hour, milliliters per minute. Then at the very end, we mentioned something called drops. The abbreviation for drops is GTT. Separate those out. So used to crossing both T's at once since I have it. And we can, the most practical way, depending on how we're infusing into the patient, is in drops per minute. I'm not hugely familiar with the technology, but from what I know, it depends on what apparatus you're using to infuse. If you have many of your electronic infusers, milliliters per minute is just fine. You program in the milliliters per minute in the substance. It calculates the drop per minute for you. Other manual infusers, you have to know the drops per minute. The type of infuser you're using also affects your rounding. Depending on the type, some infusers you would round to the nearest tenth of a drop per minute. Other infusers you have to round to the nearest whole drop. For this course, I will accept either rounding, whether you round to a whole drop or a tenth drop. I've been told that there are some infusers out there now that will go to 100th of a drop, so I will accept that as well. I'm not going to be really picky on rounding. Just don't round it off to anything larger than a whole drop. So let's take a look. Let's do a quick review of some of those calculations. Let's say we have an order to administer 800 milligrams of medication, 4 hours. our supply or the label on the bottle, however you want to look at it, is 15 milligrams in 4 milliliters. So I'm actually going to go right down through the cycle here. I'm going to find milligrams per hour. I'm going to find milliliters per hour. And I'm going to find milliliters per minute. Now, since these calculations kind of sequence off of each other, one follows off the other, it's going to break it up a little bit, but you'll get the idea. So for the milligrams per hour, we simply have 800 milligrams to be administered over 4 hours. If we divide that out, 800 divided by 4 is 200 milligrams per hour. For the milliliters per hour, if we started with the 800 milligrams per hour, we would have to make a conversion, getting rid of the milligrams and going to milliliters. We have 15 milligrams in 4 milliliters. So 15 milligrams is equivalent to 4 milliliters. Cancel out the milligrams. 800 times 4 milliliters is 3,200 milliliters. 4 hours times 15 is 60 hours. If we divide that out, 3,200 divided by 60, 53, that's milliliters per hour. Any questions so far? So if we want to do the milliliters per minute, we're going to start with that same sequence. Converting the milligrams to milliliters in the exact same way we did before. Only now we have to take the extra step. We don't want it per hour, we want it per minute. So the hours are on bottom here. To cancel it out, I'm going to put hours on top in a second conversion factor, going into minutes. So 1 hour, 60 minutes. So here we have canceled out the milligrams and we have canceled out the hours. We're left with milliliters per minute. So on the top here, 800 times 4 milliliters times 1 is once again 3,200 milliliters. On bottom, 4 times 15 times 60 minutes is 3,600 minutes. If we divide that out, 3,200 divided by 3,600, I believe that comes out to be 0.89 milliliters per minute. Any questions? The most common ones requested are milliliters per hour and milliliters per minute. Yeah, go ahead.
Now, to go from per hour to per minute, you can't just divide it by 60 because I come up with a little bit different answer than what you did in the long way.
So we did the 53.33 divided by 60. You'll get the 0.88883.
Yeah, why does it go down to the 3s instead of the 8s like it is on going the other way?
Because this number here is rounded. Technically, that's 53.3333333333. So since we already rounded that number off, we're using a rounded number to do the next calculation. So that's why that changes. Instead of being 0.888888, it drops to 0.8888 then 3. So it's just a matter of rounding. If we had kept this out to, if I am going to continue with a calculation, I would have kept that out to 4 or 5 decimal places just to make sure that rounding doesn't affect the dosage. Here it really didn't. It's still going to round to 0.89 milliliters, but it's just to avoid making sure that rounding error doesn't compound, it would go to more extra digits. Every time you write down a number and punch it back in your calculator, there's a risk of that loss, that round off error calculation. So I am going to give you an order for 200 milligrams administered over 40 minutes. And I want this given in, our supply is going to be 10 milligrams in 3 milliliters. I want you to give the flow rate here in milliliters per minute. I'll give you a minute or so to work through that. So we'd start out here with the 200 milligrams over 40 minutes. We look at what we want our result in. We want it in milliliters per minute. Here we have milligrams over minutes. The minutes can stay. We don't need to get rid of those. We need to get rid of the milligrams. So we have the equivalency 10 milligrams equals 3 milliliters. So milligrams go on bottom so that it'll cancel out. 10 milligrams is equivalent to 3 milliliters. Milligrams cancel. 200 times 3 milliliters is 600 milliliters. On bottom, 40 minutes times 10 is 400 minutes. That divides out to be 1.5 milliliters per minute. There it is, 1.5 milliliters per minute. Any questions on that one? So let's look at an order here for let's do 300 milligrams over 20 minutes. Our supply label tells us that this is 15 milligrams and 4 milliliters. I want to find my flow rate and let's say that for some reason we want this one in milliliters per hour. Give you a minute to figure that out. So we start out with our order of 300 milligrams over 20 minutes. Here we have to change both. This is currently milligrams over minutes. We want milliliters over hours. We'll start by changing the milligrams. We'll put milligrams on bottom. We have 15 milligrams in 4 milliliters. That cancels out the milligrams, and now we have milliliters on top and minutes on bottom. We want the milliliters, but we want hours on the bottom, numerator. Or in the denominator, I should say. So we need to get rid of the minutes. Minutes are on bottom here, so we'll put them on top in our conversion factor. 60 minutes equals 1 hour. Minutes have canceled, and we'll multiply it out. So 300 times 4 milliliters times 60, 2,000 milliliters, good. Over 20 times 15 times 1 hour, 100 hours. We divide that out, what is that, 240? 240 milliliters per hour. Any questions there? So where we left off last week, we had started talking about the drop factor. And a drop factor describes the thickness or the viscosity of the fluid. A fluid, it describes how many drops it takes of that fluid to make 1 milliliter. So a drop factor can range from 8 drops per milliliter to 20 drops per milliliter. That's not, an overall limit. There are fluids that are thinner or thicker than that, but most of our medications will fall in that range. So if I have that drop factor of 8 drops per milliliter, that is telling me that 8 drops is equivalent to 1 milliliter of fluid. So it's giving me that equivalency or conversion factor. So if we have an order for 1,600 milligrams of medication to be administered over, let's go 8 hours. And our supply has a label saying 20 milligrams in 7 milliliters. And drop factor, 12 drops per milliliter. We're going to be finding our flow rate drops per minute. So we start out with our order here, 1,600 milligrams over 8 hours. Both the milligrams and the hours have to be converted out here. So let's do the milligrams. We're going to put milligrams on bottom so they cancel out. We're told 20 milligrams in 7 milliliters. That has canceled out the milligrams. Next, we still have to get rid of milliliters and we still have to get rid of hours. I'm used to using the drop factor last. So I'm going to use hours next. To get rid of hours, since it's on bottom, I'll put hours on top. 1 hour equals 60 minutes. Hours have canceled out. We are now milliliters on top and minutes on bottom. Well, we want minutes on bottom, that one's good, but we don't want milliliters on top. We want drops on the top. So we have to keep converting. Get rid of milliliters, we have this drop factor. Milliliters are going to go on bottom, and that drop factor of 12 drops per milliliter tells us 1 milliliter equals 12 drops. The milliliters have now canceled out. We now have drops on top and minutes on bottom, which is what we want. So we're going to multiply across the top, 1,600 times 7 times 12 is 134,400. Drops is the only unit left on top. On bottom, 8 times 20 times 60. What's that? 600 minutes. Giving us 14 drops per minute. Questions? We'll do one more example, then I'll let you guys try some. Let's say we have an order for 200 milligrams, 3 minutes. Supply is 10 milligrams in 3 milliliters. Drop factor. Oh, let's go with 15 drops per milliliter. And we want our flow rate, drops per minute. So we're going to start out again with the doctor's orders, as always. 200 milligrams over 30 minutes. Now looking at our units here, we have milligrams on top, we want to get that into drops somehow, so that has to change. We have minutes on bottom, that's going to stay minutes. We want it to be minutes in our answer. So the minutes are going to stay. We don't have to do anything with those. We're just going to work with the milligrams, so we'll get rid of milligrams by putting it on bottom in our conversion factor to cancel it out. 10 milligrams is equivalent to 3 milliliters. Milligrams cancel out. Milliliters is still not what we want. We want to get to drops. So we use the drop factor, telling us that 1 milliliter, that goes on bottom to cancel out milliliters, is equivalent to 15 drops. So the milliliters cancel out, giving us drops in the numerator, which is what we want. 200 times 3 times 15, 1,000 drops. 3 times 10 is, 30 times 10 is 300 minutes. That divides out to give us 30 drops per minute. Any questions? Give you guys a couple to try here. Do them one at a time. So our first order is going to be 4,000 milligrams, 12 hours. With a supply of 25 milligrams in 12 milliliters. Drop factor of 20 drops per milliliter. Finding our flow rate in drops per minute. I'll give you a minute to work through that. Start out with our order. 4,000 milligrams, 12 hours. Now this is milligrams over hours. We want drops over minutes. So both units need to change. Start with the milligrams. Milligrams on bottom. 25 milligrams is 12 milliliters. So our milligrams are gone. We still have milliliters over hours, which we still need to change both of those units. I'm going to go after the hours. 1 hour is 60 minutes. Hours have canceled. We now have milliliters over minutes. We want the minutes on bottom, but we need to get rid of the milliliters. Change that to drops yet. For our drop factor, milliliters are on top here, so we need it on bottom here. 20 drops per milliliter tells us 1 milliliter is equivalent to 20 drops. Milliliters are gone. So on top, we have 4,000 times 12 times 20, which gives us 960,000 drops. Over 12 times 25 times 60, 1,800? 18,000. Okay. Minutes. And when we divide that out, we get 3.3, sound good. 53.3 or 53.33 drops per minute. Any questions on that one? Okay, one more. Our order is for 500 milligrams, 30 minutes. Our supply, 20 milligrams in 6 milliliters. Drop factor, let's go 12 drops per milliliter. And again, we're finding our result in drops per minute. Give you a minute on that one, then we'll go through it. Again, we'll start out with our doctor's orders. 500 milligrams over 30 minutes. Now, we have milligrams over minutes. We want drops over minutes. So the minutes are good. We're going to keep that. We just need to change the milligrams. Put milligrams on bottom to cancel out. 20 milligrams in 6 milliliters. Cancel out the milligrams. Need to get the milliliters now to drops. So we're on to the drop factor. 1 milliliter is equivalent to 12 drops. So on top, 500 times 6 times 12 is at 36,000 drops. On bottom, 30 times 20 is 600 minutes, giving us 60 drops per minute. Any question there? I think we're pretty good with that one, but there are times we can use that same situation, but it's not the flow rate that we need to find. Sometimes we need to figure out how long we need to leave it setting there. So we need to find the time required to infuse. Maybe you don't have the original orders, but you come in on the situation, you see the volume that's in the IV bag, and you see the setup, and you want to know how long it's going to still be there before you need to go and either change the bag or just unhook the IV. So let's say that we have a flow rate of 40, it's set at 40 drops per minute. You look at the supply, the label is telling us that it has a drop factor of 15 drops per milliliter, and it has let's just ask how long would it take? The bag volume is currently 240 milliliters. How long is it going to take to infuse that? The tricky part with these is figuring out what to start with. We are looking for a time. So we need to end up at a time. But when we're looking at any of these, if I have, let's say that 40 drops per minute, that is saying 40 drops is equivalent to 1 minute. So not only can I create this ratio, 40 drops over 1 minute, but I can also do the reverse ratio, 1 minute over 40 drops. So knowing that, it allows us to enter into this being able to flip those ratios. So if we get an answer and the time is on the bottom of the ratio, we know that we can just simply flip it over. So we'll start out with our current flow rate, 40 drops per minute. Time is on bottom of that, which means we're probably going to end up with time on bottom with our final result, but we can work with that. So that's 40 drops per 1 minute. Our drop factor, 15 drops per milliliter. Notice the drops had to go on bottom so that it would cancel out the drops that were on top in the other. Now here's the tricky part. My bag is 240 milliliters. That has to go on bottom so it cancels out the milliliters. So now if I multiply out here, milliliters have canceled. 400 times 1 times 1 is, 40 times 1 times 1 is 40. 1 minute times 15 times 240 is 3,600 minutes. And you see that we did come up with a fraction where the time is on bottom. That's just saying 40 over 3,600 can be flipped to be 3,600 minutes 40. Which divides out to be 90 minutes. We're so used to starting out with the orders or the first piece of information. It's reflex here to start out with that flow rate. In a case like this where everything is given in rates except for one number, 240 milliliters is the only number that's not a rate. Typically, that's the number you're going to want to start with, is the one that's not a rate, because everything else is really a conversion factor. Had we started with the 240 milliliters, we wouldn't have had to flip a ratio during the calculation, put time on top. Let's do an example where we go through it in that direction. So for this example, we have 2,400 milligrams of fluid in the bag. It is currently infusing at 45 drops per minute. And the supply tells us that this is 40 milligrams in 15 milliliters of solution. And the drop factor is currently 19 drops per milliliter. Notice all three of these are rates, which means they give us equivalencies. We're going to start with the one that is not a rate, 2,400 milligrams. So I have milligrams. I need to get rid of that first. I'll put milligrams here. 40 milligrams equals 1,500 or 15 milliliters. Milligrams cancel out. We still need to get rid of the milliliters. Those on bottom. We have our drop factor. 19 drops per milliliter, so 1 milliliter is 19 drops. So the milliliters, still we don't want drops, we want a time unit. So we have our current flow rate of 45 drops. Drops go on bottom, so they cancel out per 1 minute. Drops canceled out. The only unit we have left is the minutes. So on top, we've got 2,400 times 15, 19. We got 684,000 minutes. On bottom, we've got 1 times 40 times 1 times 45, which is what, 1,800. 684,000 divided by 1,800. 380 minutes. I'm good with leaving it like that, but if you wanted to, you could divide by 60 minutes in an hour. Now, the reason I didn't just do a conversion factor, the reason I didn't just do 380 minutes over 1 times 1 hour over 60 minutes, because this isn't going to come out evenly. The minutes would cancel out. You'd end up with 380 divided by 60, which is going to give you 6.33333. So in order to figure that out in hours and minutes, if I take my 380 minutes divided by 60, goes in there 6 times. 6 times 60 is 360, left with 20. This number up here is the whole hours. That's 6 hours. Number that's down here, the remainder, is the remaining minutes. So that 380 minutes, 6 hours and 20 minutes. Any questions? Okay, it's 11:20. It's time for a break. So let's take a few minutes here. We'll come back at 11:30 and we'll do some more of these. I'm going to put one of these up here for you to work on over break if you would like. So let's say our bag, 1,500 milligrams, is currently set at a flow rate 24 drops per minute. Supply label states it's 25 milligrams in 8 milliliters. Drop factor of 12 drops per milliliter. Again, please take a break. If you get back early and want to work on that, go for it. Start up again at 11:30.
Yeah. Yeah.
Or did he go over? I tried to make a stupid video. I was kind of looking through them yesterday because I had a hard time finding them. They're like under S or course information. And then I found them prior, but it didn't have last week's. Oh, really? Forgot to post it or something.
But he went over it really good just now.
I mean, last week we just did
Okay, it's 11:30, so let's go ahead and go through this one. So our IV bag currently contains 1,500 milligrams of fluid. get rid of the milligrams. We have 25 milligrams and 8 milliliters. So we'll have to get rid of the milliliters. We will use drop factor. Milliliters on bottom, 12 drops on top. Canceled out the milliliters. And we have our flow rate there, 24 drops. So drops are on top here, we gotta put the 24 drops on bottom, is equivalent to 1 minute. So our drops have canceled out. So we have 1,500 times 8 times 12 on top, giving us 144,000 minutes. On bottom, we have 1 times 25 times 1 times 24, 600 minutes, giving us 240 minutes. Well, since that one's going to divide out nice and evenly, 240 minutes over 1, and I know you most likely don't have to do the conversion factors, but I'll go through it. 1 hour is equivalent to 60 minutes. Minutes cancel out. 240 over 60 does give us 4 hours. The time to infuse. Any questions on calculating infusion time? Now, of course, there are other things in that formula that can be calculated. For example, let's say we have the setup, but we don't know what the drop factor of the fluid was. We need to set up the same fluid in another infuser, but we don't have the drop factor given. So let's say we do have a flow rate of 50 drops per minute. And we know that the order is 750 milliliters over 5 hours. Both of these are rates, they're equivalencies. This is saying 50 drops is equivalent to 1 minute. This is saying 750 milliliters is equivalent to 5 hours. We're looking for a drop factor. And a drop factor is going to be in drops per minute. So let's take whatever we have that has drops in the numerator. That's our flow rate. 50 drops per 1 minute. Now, unfortunately, we don't have anything else that equates drops to anything or minutes to anything. But we do have this, the 750 milliliters over 5 hours, that equates hours to something. And if we have minutes, we can get it into hours. Minutes on top here, 60 minutes is equivalent to 1 hour. The minutes cancel out, and we now have it in drops per hour. From there, then, we can use 750 milliliters over 5 hours. Hours are on bottom here, so I'm going to put hours on top. That's 5 hours. 750 milliliters on the bottom. The hours have canceled out. So on top, we've got 50 times 60 times 5 is what, 15,000 drops. On bottom, 1 times 1 times 750. That should be 1,500, not 50. Check it. What is 15,000? Divided by the 750 gives us 20 drops per milliliter. There is our drop factor. Now, we might not always be given quite that exact information might be given that we are infusing 2,000 milligrams over 8 hours, and that our supply states that it is 25 milligrams, 12 milliliters, and a flow rate is set at 30 drops per minute. So again, we're still looking for that drop factor, which has drops in the numerator. So we're going to start with something else that has drops in the numerator. 3 drops per 1 minute. So we don't want to change the drops really. We want to get rid of the minutes to get this in drops per milliliter. Up here, I don't have anything else that's in minutes. So I'm going to have to change my minutes into hours so that I can work with the hours. 60 minutes for 1 hour. I'll have drops per hour. And I have this relationship here, 2,000 milligrams in 8 hours. So I'll put the 8 hours on top, so the hours would cancel. 2,000 milligrams on bottom. The hours cancel. What I currently have is drops per milligram. I don't want drops per milligram. I want drops per milliliter. So we have to keep going. I have this relationship here of 25 milligrams in 12 milliliters. That will cancel out my milligrams and leave me with milliliters, which is what I want, drops per milliliter. So now on top, got 30 times 60 times 8 times 5. It's 360,000. Units on top is drops over 1 times 1 times 2,000 times 12 milliliters. 24,000 milliliters. 360,000 divided by 24,000 gives us 15 drops per milliliter. Any questions there? So we might also be asked to find the total volume of fluid infused. So we have a setup that is currently running at a flow rate 45 drops per minute. And our supply says that we have a drop factor of 15 drops per milliliter, and it is set for a runtime of 3 hours. Find the volume, total volume that would be infused here. Well, we have 3 hours, which is currently not a rate, so that's what we're going to start with, is our one number that is not a rate. 3 hours over 1. Well, currently we don't have anything else that's in hours, but we do have minutes, drops per minute. So let's take a look at that. I'm going to convert my hours, 1 hour, 60 minutes. The hours are gone, I now have minutes. Now I can use that drop factor, not the drop factor, the flow rate of 45 drops per minute, convert time into a volume. In this case, it'd be drops. So the minutes will go on bottom to cancel out. 45 drops is equivalent to that 1 minute. Minutes are gone. now I have drops. I look and I have my drop factor. Cancel out the drops. I put the 15 drops on bottom per 1 milliliter. And those drops will cancel. So right now the only units I have is milliliters, which is what I want. I want my volume of fluid infused. 3 times 60 times 45, 8,100 milliliters. On bottom, 1 times 1 times 1 times 15 is 15. 8,100 divided by 15 gives us 540 milliliters of fluid infused. Any questions? So a slightly different vein. Still trying to find the total volume infused. We might check and see that the flow rate is set. 45 drops per minute again. From our supply, we might see that we have a drop factor, 15 drops per milliliter, and that it's concentrated at 20 milligrams, 6 milliliters. And we have our run time set at 4 hours. So again, we'll start with the only thing we have there that is not a rate or an equivalency. That's our run time of 4 hours. Just like before, everything else is in minutes, so we're going to have to get those hours into minutes right away. The hours go on bottom to cancel out hours. 60 minutes on top. Now have minutes. So the only thing that we have here with minutes is our flow rate. Put minutes on bottom so that it cancels out. That's saying 1 minute is equivalent to 45 drops. Count the minutes. When I get rid of drops, that brings us to our drop factor. Drops are on top, so we're going to put them on bottom to cancel them out. 15 drops is equivalent to 1 milliliter. Canceling out drops. Now in this case, I wanted to find the milligrams of fluid used. I should have specified that. So I want to get rid of the milliliters, putting them on bottom. 6 milliliters is equivalent to 20 milligrams. Milliliters cancel out. On top, I've got 4 times 60 times 45 times 20, 216,000 milligrams over, on bottom, 1 times 1 times 1 times 15 times 6, 90, giving me 2,400 milligrams of medication infused. Any questions? If we have time at the end of the class, I will come back and give you guys a couple of examples of those to try on your own. For right now, I want to move on to our next topic, just so we don't run out of time. And that is, we're going to talk about dosages based on weight. So many of our medications, the amount that should be administered depends on the weight of the patient. Now, when we're talking metric, we're technically talking about dosages based on mass, but remember we blur those words a little bit in medicine. Our label or recommendation might say something like 0.4 milligrams per kilogram per gallons. So it not only specifies an amount, it specifies how often that amount can be administered. To start our calculation, we will usually ignore that time frame of 8 hours. We're not completely getting rid of it, we're just setting it aside and we're going to put it back on when we're done. Whatever our result is, we know that is a dosage for an 8-hour period. So we're working with 0.4 milligrams per kilogram. Let's say we have a patient that comes in at 88 pounds. Well, our first step is going to be to convert that patient into kilograms. This is something that happens often enough. We could very well set that up as 88 pounds over 1 and do the conversion factor of 2.2 pounds is equivalent to 1 kilogram. It's going to end up giving us 40 kilograms. But this is a conversion that happens enough that we're going to just go ahead and take a little bit of a shortcut. Whenever you see those pounds, you divide by 2.2, get the kilograms. It saves us from using an extra conversion factor. So now from that 40 kilograms, our dosage calculation will start. So this is saying 0.4 milligrams per kilogram. So kilograms go on bottom. That's 1 kilogram is equivalent to 0.4 milligrams. So the kilograms will cancel out. 40 times 0.4 milligrams is 16 milligrams. So that patient should receive 16 milligrams of that medication. Questions? And of course, you put the time back on it before we finish up. That is 16 milligrams every 8 hours. So if our label says 1.5 milligrams per kilogram per 6 hours, we have a patient that comes in at 132 pounds. Let's find our single dose. So our first step, divide by 2.2. The 132 pounds is 60 kilograms. So then we'll start with that 60 kilograms. We'll put it over 1. If 1.5 milligrams per kilogram says 1 kilogram is equivalent to 1.5 milligrams of medication, kilograms cancel out. 60 times 1.5 is 90 milligrams over 1. So that's simply 90 milligrams for 6 hours. You know me at all by now, you know I don't keep it quite that simple. So let's say our label is 0.5 milligrams per kilogram, 8 hours. And it is concentrated at 20 milligrams in 9 milliliters. We have a patient who comes in at, well, let's go 88 pounds. So our first step, as always, is to make sure that the weight of our patient is in kilograms. Figure 88 pounds divided by 2.2, giving us 40 kilogram patient. That's where we start our dosage calculation, is at 40 kilograms over 1. We have 2.5 milligrams per kilogram, saying that 1 kilogram is equivalent to 2.5 milligrams of medication. We've canceled out the kilograms, we're in milligrams. For this medication, though, since it says 20 milligrams and 8 milliliters, that's telling us it's a fluid or a liquid solution is the medication. So we need to know how many milliliters to administer. We'll cancel out the milligrams. This tells us that 20 milligrams is equivalent to 9 milliliters. Milligrams cancel out. So we now have 40 times 2.5 times 9, that's 900 milliliters, over 1 times 1 times 20 is 20, which divides out to be, 45 milliliters to administer. Again, that is our time frame here is 8 hours. Have you guys tried one? So our label tells us that this is 0.8 milligrams per kilogram, 4 hours, and that we have a concentration, 10 milligrams, 6 milliliters. We have a patient coming in at 110. Find the amount of milliliters of fluid you should administer to that patient. So we start out by taking our 110 pounds, we'll divide by 2.2, get the 50 kilograms for our patient. Start off with our 50 kilograms in our calculation. 1 kilogram is equivalent to 0.8 milligrams. Kilograms are canceled out. Cancel out milligrams, 10 milligrams is equivalent to 6 milliliters. Cancels out the milligrams. We multiply it out. 50 times 0.8 times 6 is 240 milliliters. 1 times 1 times 10 is 10. 240 milliliters divided by 10 is 24 milliliters every 4 hours. Any questions there? So some questions come up. What if doctor orders you to administer recommended dose every 6 hours? The label says 1.2 milligrams kilogram every 8 hours. Let's say that our label also says that this is constituted at 12 milligrams in 5 milliliters. And let's have a patient who is 121 pounds. So our first step is going to be change the pounds into kilograms. Dividing by 2.2 gives us, what is that, 55 pounds? 55 kilograms. Start off their dosage with the 55 kilograms. So again, 1.2 milligrams per kilogram tells us 1 kilogram is equivalent to 1.2 milligrams. Get rid of milligrams, we use 12 milligrams on bottom in 5 milliliters. Canceled out the milligrams. So now on top here we have 55 times 1.2 times 5 milliliters. I believe that's 330 milliliters. On bottom, 1 times 1 times 12 is 12. If we divide that out, what do we have, like 27.5 milliliters? But that is every 8 hours. Our doctor wants it administered every 6 hours. Do this adjustment, we could actually do a conversion. The conversion that we use is called a titration. Titration can be used for a couple of different things. One is to adjust time. By time, I mean frequency of administration. The second, titration can be used to adjust minimum or maximum dosage if there's a range given. So far, every dosage I've given you is just a flat so many milligrams per kilogram. I haven't given you a range yet. That's coming up. So for this dosage, at 27.5 milliliters, 8 hours. I'm not going to put the 8 hours on bottom. I'm just going to go with the 27.5 milliliters. And my titration is going to have on bottom, it's the old time. In other words, that's the time that was part of our calculation. That'll be the 8 hours here. And on top, we want the new time, new frequency. Be 6 hours. It's always the old on bottom, the new on top. This 27.5 was calculated for the 8, so the 8 goes on bottom. We want to change it to how much for 6 hours. So that's just multiplying it out. Of course, the hours will cancel out here. So it's just going to be 27.5 times 6 divided by 8, giving us 20.625. So 20.63 milliliters, 6 hours. Now, I mentioned another use for those titrations is if we're given a range of dosages. So if our label gives us something like 1.75 to 2 milligrams per kilogram per 12 hours. And the rest of our label tells us this is constituted 25 milligrams in 8 milliliters. Let's work with a patient who is 66 pounds. So as always, our first step, turn our pounds into kilograms. 66 pounds divided by 2.2 is 30 kilograms. I should make a little bit of a side note here. I have chosen the pounds for my patients carefully for these examples so that I get a nice neat number for kilograms. After this example, I'm not going to do that anymore so that we can see the ugly rounded numbers. But for the first few examples, I wanted the numbers to stay simple. Probably because it makes it easier on me too. So anyway, we start with our 30 kilograms. Our next conversion is always to convert kilograms into milligrams. The difference is we have two numbers here, so we can pick one. Either the minimum dose of 1.75 milligrams per kilogram or the maximum of 2 milligrams. I'm going to pick the 2 milligrams per kilogram. So the kilograms cancel out, we have 2 milligrams. Then I'm going to do the conversion from milligrams to milliliters. 25 milligrams equals 8 milliliters. My milligrams will cancel out. So 30 times 2 times 8 is, what is that, 480 milliliters? 1 times 1 times 25 is 25. 480 divided by 25, giving us 19.2 milliliters every 12 hours. Remember, that is the maximum dosage. I want to find the minimum dosage. I could go back and do the whole calculation over again with the 1.75, but we don't have to. We can use that titration technique again. So we start with our calculated dosage of 19.2 milliliters. That was calculated using the maximum dose of 2 milligrams. Want to convert it to the minimum dose of 1.75 milligrams. Again, note that the milligrams cancel out. Also note, again, the number that goes on bottom is the number that this current one was calculated from. That was calculated using the 2 milligrams. The number that goes on top, that's the new one that we want to change it to. So this again is going to be simply 19.2 times 1.75 divided by 2. You get 16.8. So the minimum dose would be 16.8 milliliters every 12 hours. Questions? I'm going to have you guys quickly find maximum and minimum dose. If our label says 2.5 to 3 milligrams per kilogram per day, and 15 milligrams in 15 milligrams in 8 milliliters. The patient, let's give our patient 143 pounds. So find the minimum and maximum recommended dose for that patient. we start out with our 143 pounds, divide by 2.2, we get 65 kilograms. Start out with 65 kilograms. I'm going to choose to use the maximum first. That's telling us 1 kilogram is equivalent to 3 milligrams. We'll convert our milligrams, so 15 milligrams on bottom, so it cancels the milligrams, 8 milliliters. 65 times 3 times 8, giving us 1,560 milliliters over 1 times 1 times 15, which gives us what? 104 milliliters per day. Now I use the larger of the number, so that is the max dose. Find the min, at 104 milliliters, and I multiply. I use the 3 and I want to convert it to the 2.5. Notice I didn't even put the milligrams on there this time because the milligrams are just going to cancel out anyway. It's 104 times 2.5 divided by 3. Give us 86.67 milliliters per day is our minimum dose. So let's say we have an order to give recommended dose every 8 hours. Our label recommends 5 to 6 milligrams per kilogram for 12 hours. Label says 5 milligrams in 12 milliliters. And our patient is, well, let's make it 66 pounds. So here's a spot where we're going to have to use our titrations twice. Once because we have to change our frequency of the dosage. Then the second time to do the maximum minimum. So we start with our 66 pounds. We're going to divide by 2.2, get 30 kilograms. We're going to use the maximum dose of 6 milligrams per kilogram. So 1 kilogram is equivalent to 6 milligrams. Converting milligrams to milliliters. Milligrams on bottom. 25 milligrams is equivalent to 12 milliliters. Milligrams have canceled out. 30 times 6 times 12, 2,160 milliliters. 1 times 1 times 25 is 25. So we divide out the 2,160 divided by 25 is 86.4 milliliters, but that is per 12 hours. Doctor wants it every 8 hours. So we're going to perform that titration. 86.4 milliliters, that is calculated per 12 hours. We want it to 8 hours. Again, I could put the hours on there, but they're going to just cancel out anyway. 86.4 times 8 divided by 12. 57.6 milliliters, and that would be for an 8-hour dose. That is the maximum dose for 8 hours. Find the minimum dose for 8 hours. We take that number and we do the titration with it. 57.6. Turn back up. Milliliters, again, I'm leaving the time frame off. The 57.6 was based off of 6 milligrams per kilogram. We want to convert it to 5 milligrams per kilogram. Based off 6, we're converting it to 5. So we're going to take that 57.6 milliliters times 5 divided by 6, giving us 48 milliliters. The time frame is still 8 hours. Is our minimum dose. So that dosage that we would be recommended for the patient is 48, 57.6 milliliters every 8 hours. Any questions? How many of you are totally fried at this point? That's a lot of information in 2 hours. We have one more week of this before our test. So our test is 2 weeks from today. I believe that's November 8th. So next week we'll go over a little bit more of the dosages based on weight. We still have to do dosages based on body surface area. And then we'll do some more problem examples of calculating flow rates, dosages, finding the missing numbers like the volume infused and time infused and all that. For now, pages out of the book to work on. 172 to 173, 1 through 9, the odds. That's just talking about how to reconstitute a solution. A lot of the medications we get come with a vial with a powder in them and no liquid in them. That's just telling you how much liquid to inject into that vial to constitute the solution. Page 178 to 179, this is the dosage calculations. 1 through 21, the odd. The flow rates. Page 184, 1 through 11, the odd. And finally, this is it, this one. Page 188 through 190, 1 through 21, the odd. That's our dosages based on weight. Anybody have any questions? Okay, let's have a great week. We'll see you next week.